This is a video recording for Chapter 7, Part 2 on quadrilaterals. Quadrilaterals are four-sided figures, and here are some examples of quadrilaterals. The first one in the notes will be a trapezium. And the description is that there is only one pair of parallel lines, and these two lines, they are opposite of each other. So if there are two pairs of parallel lines, it will no longer be a trapezium. Next, in the diagram, we have a parallelogram. In a parallelogram, opposite sides are parallel to each other. So these two, as indicated by one arrowhead, and the other two opposite lines, the other two opposite sides, as indicated by two arrowheads over here. Opposite sides are also equal in length. So when you want to use this property, you call it as opposite sides of parallelogram as the abbreviation. Opposite angles are also equal. So this angle and these two, they are the same. Similarly, for these two and these two, because they're opposite each other, they are the same. The last property of this parallelogram is that the diagonals, they bisect each other. The diagonals start from here and reaches across to the other side of the parallelogram. This is one diagonal. The other diagonal in blue over here. So this red diagonal and the blue diagonal, they cut each other, they intersect each other and divide each other into two equal halves. And these are the abbreviations if we want to use any of the properties. Next, we have a rectangle. And these are the properties. You should be familiar with all of them already. Next, we have a rhombus. A rhombus is like a parallelogram, but there are a few other properties. That is, all sides are equal in length. So if you compare that to a parallelogram, only the opposite sides are equal. But for the rhombus, all of the sides are equal in length. And again, opposite angles are equal. Take note that not all angles are equal. Only opposite angles are equal. Next, part D, the diagonals, this time they bisect each other, not just dividing each other into two parts, but also they bisect at right angles. So here, 90 degrees, 90, 90, and 90 degrees. One more property for the rhombus is that the diagonals, they bisect the interior angles. So for example, if you're looking at this angle in blue, and this red diagonal is now going to divide the blue angle into two equal halves. Likewise for the other angle in green over here, it is separated into two equal halves by the other diagonal. So here, moving on, we have a square, and you should be familiar with the properties. Finally, we have a kite. So it looks like a kite, but in a kite, there are no parallel sides. There are two pairs of equal adjacent sides. Okay, so this green side and this side, they're adjacent to each other and they have equal length. The other two sides at the bottom, they also have equal length. The diagonals will also bisect. Okay, not all diagonals are bisected. Only this shorter diagonal is divided into two equal halves by the longer diagonal cutting down the kite. And just like the rhombus, the diagonals meet at right angles.